Okay, let's see. So we have question number 48. So we can see 3 stars each of mass m are at the vertices of an equilateral triangle. This is the equilateral triangle of side length a as shown in the figure. Suppose the 3 stars rotate in a circular path about the centroid of the triangle. So it goes around the centroid of the triangle by retaining the initial distances between the stars. If only mutual gravitational forces acting among the stars, the periodic time of the system is given by. So if we look at this mass m is attracted by this mass m here, the force F. This mass m is attracted by this mass m, the force F. So these are gravitational forces of attraction. So then the resultant force is going to be what? 2F cos 30 towards the centroid. Right, so yeah, I'm going to represent, now I can't mark everything here, so I just marked the distance from this mass m to the centroid. It's going to be x. Right, so, okay. Now what's the gravitational force equal to? F is equal to what? Product of the masses, right, times universal gravitational constant, divided by what? Distance between them squared. Actually, I take this as capital M because in the answer they have given capital M, right? Okay. So you get what? 2F cos 30 towards the centroid. So you get gm squared over what? What's r squared here? R squared is what? A squared. Right? Distance between the masses is simple A. Okay, times cos 30. What's cos 30? We get what? Yeah, so 2 times f cos 30, right? 2 times f cos 30 towards the centroid. So 2 times what? Gm squared over A squared times cos 30. Cos 30 is root 3 over 2. Okay, this is the force towards the centroid. So this is acting like what? A centripetal force. It should be equal to what? M r omega squared. That should be equal to what? M. What's r here? Radius is what? X. So what is x here? We can say x cos 30 is equal to what? A over 2. If this entire length is A, this is going to be A over 2, right? Then x times what? Root 3 over 2 is equal to what? A over 2. 2 and 2 cancels, and x is equal to what? A over root 3. Right. So we have what? M times A over root 3 times omega squared. What is omega squared? Omega means 2 phi over t. Then 4 phi squared over t squared is equal to omega squared. So we have here what? 4 phi squared over t squared. Right. So I have what? 2 gm. So 2 and 2 cancels. Let's simplify. Yeah, that's it. So 2 gm squared over a squared times root 3 is equal to what? Capital M a over root 3 4 phi squared over t squared. Then eventually I can say what? T squared is equal to what? Yeah, what's t squared equal to? Root 3 can be taken down, then root 3 times root 3 becomes 3. Then I have what? Down I have what? 3 times, I can take gm squared down, gm squared. Then a can be taken, a squared can be taken up. Then a squared times a is what? A cube. And then, okay. And also, can you see, like, I have m squared here and m, so it cancels, right? So 1m only remains, then gm downwards, right? So therefore, I have this equation, and then I should take what? Square root of 4 phi. Square root of 4 phi is 2 phi. So I have what? T is equal to what? 2 phi times square root of what? A cube over 3 gm. I hope we can understand this equation, right? Yeah. So the answer is going to be what? The first one. Now the answer is going to be the second one, right? Answer is the second one. All right. Then we have question number 49. Question number 49, what does it say? Block A of mass 2 kg and block B of mass 6 kg are placed on a frictionless horizontal surface. Two identical springs of negligible mass are placed to the blocks as shown in the figure. Block A is projected with a speed of 2 meters per second, and it is projected towards what? Block B, which is at rest. What is the maximum energy that the two springs could retain or attain, right? Yeah, let's see that. So here I have what? A mass of 2 kg. It has a velocity of 2 meters per second. It's connected to spring like this. And here I have what? A mass of 6 kg. It's connected to spring like this. Right, so this is going at 2 meters per second. Now listen. They're asking what's the maximum energy that the two springs could attain. Okay, so we can apply the conservation of linear momentum first. Now we can apply the conservation of linear momentum to the system. Why the system? Because when these two springs strike, when the two masses strike, these two springs strike, those forces are going to be internal forces. When you consider the system as a whole, the two internal forces are going to cancel off. Therefore, if there are no external forces on the system, the linear momentum of the system should be conserved. So I can say what's the initial momentum of the system? 2 times 2, 4. That should be equal to what? The final momentum of the system. What's the final momentum of the system? The total mass, finally, of this strike, they're like this, right? Total mass finally is what? 8. 2 plus 6 kg is what? 8. Velocity is x. So x is going to be equal to what? Half meters per second. Okay, what's the initial kinetic energy? Initial kinetic energy is equal to what? Half mv squared. What's mass? 2. What's velocity? 2 squared. V squared is what? 2 squared. Therefore, we get 4. Therefore, what's the initial kinetic energy? 4 joules. Half mv squared. Half times the mass is 2 kg. Velocity squared is 2 squared. So you get 4 joules. What's the final kinetic energy? Yeah, what's the final kinetic energy? Half times the final mass, 8, times the final velocity squared, half squared, which is what? 1 over 4. Then you get what? 1 joule. Right, down we have 8 now, and up we have 8, so cancels off. So what's the energy difference? The change in kinetic energy is equal to what? 3 joules, right? 4 minus 1. So if there is no other loss of energy, like through friction or anything, if there's no loss of energy, what can we say? If there is no loss of energy, because they have mentioned it's a frictionless horizontal surface, if there's no loss of energy, then this energy should be trapped within what? The springs as potential energy. So what's that energy difference? 3 joules. So 3 joules should be trapped as what? Potential energy in what? The springs. So that's the answer. So the answer is the fourth one. Right. So question number 50. We have question number 50. 5 thin flat metal plates, each of area capital A, are kept parallel in vacuum with an equal gap D. If plate P is connected to S and R is connected to T using conducting wires as shown in the figure, the equivalent capacitance between terminals X and Y is given by. So now listen, better calm down and do this question. You should not panic. So let's see. I have what? First represent the question. Plate P, Q, R, S, T, and I have terminals X, terminals Y, and the gap between them is D. P is connected to S, and R is connected to T. Right. So they're going to ask us the equivalent capacitance between what? X and Y. So let's see. There's nothing wrong in writing a capacitor like this. Is equal to what? This. It's for convenience. Nothing wrong. So I'm going to use this conclusion. Now I'm going to write P like this. And then Q. Again Q. You'll see why. Because I can connect them, right? So just write it as Q. Right? It's the same thing. And then again what? R. So I can write R like this. Then again S. So I can write S like this. Then T. I don't have to do anything to T. So this is R, this is S, this is T. Be very careful, right? So X is connected like so. Y is connected like so. Okay, what can we do? And also there's another connection. R is connected to what? T. Therefore I can connect it like this. Now it looks more familiar, right? It looks more familiar. Okay, what can I do? I can simplify this further, right? How can I? I can take this up to make it like more appealing, right? Make it more appealing. So how can we make it more appealing? Like this. And also remember, P is connected to S, no? So P is connected to what? S, like this. P is connected to S. I can make it more appealing. I can take this capacitor here. I can write it then. I have X and Y, and here are the capacitance. And Y is like this, right? Yeah. So I have the capacitor here, and I can take it up like that. Nothing wrong, right? Yeah. So X is here, and then I have this, and I can take this down, right? I can take it down, and then it becomes what? This. And then I can take it what? To S, S point S. Be very careful, right? Yeah, this S. Okay. Each of the capacitors have what? Capacitances of what? C. Okay. So C and C, like this. If they're parallel like this, what's the equivalent capacitance? 2C. So when they're like this, the equivalent capacitance is 2C. So I have X and Y, right? And I get what? Capacitance of what? 2C. When they're parallelly, you have to just add them. 2C. But where is Y? Y is still here, right? And then down I have what? C. Now 2C and C, they are in series. Therefore, the equivalent capacitance is going to be what? The product of the two capacitances divided by what? The addition of the two capacitances. 1 over C is equal to 1 over C1 plus 1 over C2, right? That's the equation. So you can do it mentally. 2C times C divided by what? 2C plus C. So 2C divided by what? 3C, right? It's going to be the equivalent capacitance of 2C and C because they're in series. Then I have X and Y here. C like this, and then I have what? 2C over 3. So C and 2C over 3, they are parallel to each other. Then equivalent capacitance is going to be what? C plus 2C over 3. C plus 2C over 3 means what? 3C over 3 plus 2C over 3. That means what? 5C over 3. So equivalent capacitance between X and Y is going to be what? Eventually 5C over 3. You know, capacitance can be written like this. Now I erased some of the diagrams. If I have two plates like this, and the gap is D, and the permeability is epsilon naught, I can say C is equal to what? A epsilon naught across surface area. Here's A, right? And I can say what? C is equal to what? A epsilon naught divided by D. So here I have what? 5C over 3, right? I have 5C over 3. Then I'm going to multiply by what? 5C over 3. Then this becomes what? 3 like this. What's the answer? The answer is going to be 5 A epsilon naught divided by 3 D. So the answer is the second one, right? Now this is the end of the paper discussion. I hope you can understand these things. Sometimes I'm not that used to online classes, therefore I'm used to online classes where kids are there, like children are there, and they question you, and then they say that they can understand, and then I can see them physically, I can hear them physically, right? Yeah, though it's online, like I treat it as an online, as a physical class, because I can hear their voices. But now here, what happens is, like, I'm just looking at a camera and teaching. So I hope you can understand. Yeah, I tried my best, right? Just learn something from these discussions. What you can do is try to understand the theory well first, right? Try to really understand the theory and then try the questions. And after trying the questions, to confirm your answers, listen to the discussion, and then through the discussion, you know where you are weak at. And then go through your theory notes and try to improve your weak points. And next time, get all this knowledge from this paper discussion, and then go to next paper, like 2019 or some paper, and then use this knowledge and do those papers, right? So do other past papers too, and then get the knowledge, right? Okay, thank you for listening.